and we are back again for Module 5, Lesson 3, Estimate Irrational Numbers. We're picking off where we left off with a screaming cat, and Example 3, Estimate cube roots to the nearest integer. And here's the screaming demon herself, Tilly. She just loves to scream. So, we want to know what is going to be an estimate of the cube root of 320. Now remember, cube root is a number that's multiplied times itself 1, 2, 3 times in order to get to equal 120. And the question asks you to think about what are, look out cat, some of the perfect square cubes that are close to 320. Well, the two perfect cubes I know right off the top of my head. Perfect cube of 5, that's 5 cubed, is going to be 125. 10 cubed is going to be 1,000. Now those two are pretty far apart. But I also remember that I just worked 7 cubed a little while ago, and 7 cubed was equal to 343. So that is going to be my starting point when I go to it. Let's see what the textbook says to do. It says find two perfect cubes which 320 lies between, and then find their cube root. So the greatest perfect cube that is going to be less than 320 is going to be 216. Give you a hint, they said it right here. And the cube root of 216, that's going to be 6. The least perfect cube that is greater than 320, that's going to be 343. Oh, dang cat messed me up here. 343. And of course the cube root of 343 we have already discussed is 7. Check your answer, and your answer checks. From there, it's going to work just like the others we've done before. Is 320 going to be closer to 343? Or is 320 going to be closer to 216? I think you know the answer to that one. It's going to be pretty darn obvious. So, what are we doing here now? They want us to plot them on the number line. So, the cubed root of the 216, that was going to end up being 6. The cubed root of 343, that was going to end up being 7. Oh, let's try that again. 7. And then we need to figure out where 320 is going to be. The cube root of 320. And it's 23 away from 343, but it is 104 away from 216. So we're talking about a difference of it's about a 4 out of 5 ratio, I'm thinking. So I'm going to take and put my last point 4/5 the way. So that's 3/4, 1/2, or this 3/4 right here. 4/5 would actually land it about right there. So somewhere around there is what I'm thinking it's going to be. Now let's zoom out and compare what the textbook says. The textbook said that, I said this. I was fairly close. Either way, when you do it, you see it's very clear that the cube root of 320 is going to be closer to the cube root of 343, which is 7, than it is the cube root of 216, which is 6. Jump back up here to our problem, and from here, we're going to look at it as a set of inequalities, and we're going to use that to estimate the roots. And quite frankly, this part here, this is the honest to goodness supporting work you'd be looking at doing. So, you've got the cube root you have 216 is less than 320, which is less than 443. From there, if you were to take the square roots, yes, you do need to put radicals over them. You've got to do that. We could say that well, they chose a different row. They said 6 cubed is less than 320, which is less than 7 cubed. That'll work. It's not the way I would do it. And then they went from there and said the cubed root of 6 cubed, yada yada. So they took this line here, put the cubed radicals over everything, and from there they came down to this. And from there they came down to the fact that since it is closer to 7, that 7 is going to end up being your correct answer. I guess I could zoom in on that a little bit so y'all could see it better. But that's a gist of how you're showing your work. I do mine a little bit different, and I'm going to show you how I do mine on your extra example. But you guys go ahead now, log in or jump onto your extra example. Let me reset this one, And you guys get on your extra example and work it on your own. Check your answer and see if you're right. And what you're looking for is a cubed root of 100. That one shouldn't be too hard. Alright, my turn. You remember earlier I mentioned the fact that the cubed root of 5 was, or the cube of 5 is one of the ones that I knew. 5 times 5 is 25 times 5 is 125. So that's going to be my starting point because I think that's going to be pretty close. So I'll put the cubed root of 125 here, and then over here I'm going to take and say, well, what is the cubed root of 4, or what is 4 cubed going to be then? 4 times 4 is 16. 16 times 4 is 64. Does 100 lie in between 64 and 125? Absolutely it does. From here I'll say the cubed root of 64, that is going to equal to 4, which will be less than the cubed root of 100, which will be less than, oops, need my cube there, the cubed root of 125, that's going to be 5. Now we've got to decide which one's closer. 100 is closer, is 25 units away from 125. 100 is going to be 36 units away from 64. It's closer to 125. Therefore, I'm going to say that the cubed root of 100 is going to be about 5. Since it's closer to the 125, that means it's closer to 5 for its cubed root. Not that hard if you know your cubed roots. So getting back here to our problem, I'm going to take and type in my final answer here. I selected 5. We're going to hit check, and our answer checks. Everything's good. And now we're going to take and do something I've honestly never done before. So I'm going to be learning here too, or if I have done it, I don't remember it. You can estimate irrational numbers using a calculator by truncating the decimal expansion. And it says truncating is a process of approximating a decimal number by eliminating all decimals past a certain point. So basically what they're saying is we're going to say, yeah, we'll just stop at the 4th decimal or something. Everything after that, we're just going to kick it to the curb. It doesn't matter. So here you've got the square root of 12, which is all of these pretty numbers right here. And in that, we're going to take and say, well, what if we wanted to drop all the digits after the tens place? That would be called truncating or dropping. And hey, guess what? I have actually done that before. I just never called it truncate. And then from there we say, well, what if you wanted to truncate everything after the hundredths place? It would look like that. What if you wanted to truncate or drop everything after the thousandths place? It would look like that. Really not a difficult concept there. So with that, how could you continue to truncate the square root of 12 to get better approximations? Well, the more decimal places you include, the more exact your answer is going to be. And it says if you rounded square root of 12 to the nearest tenth, what would your approximation be? And if you rounded and if you truncated it, what would the approximation be? Well, let's go back and look at that tenths one over here. To the nearest tenth, that 6 would have rounded that to be 3.5, but it would have truncated it to be 3.4. So on this aspect, I don't think I've ever done that. I've always rounded. I've never just said, nah, we can kick those numbers to the curb and not bother rounding. For example 4, Wyatt wants to fence a square portion of his yard to make a play area for his new puppy. The area covered is 2 squared meters, which really isn't a whole heck of a lot of area for a puppy to play in. So we're going to take and say, great, 2 squared meters. That means that each side is going to be the square root of 2 squares. So, because remember, area of a square, side times side, is equal to the area. So if you to get from the area back down to it, you just take the square root. We've done that before. Here you can see that the approximate amount of fencing he will need to do the perimeter is going to be 4 times the square root of 2, because the square root of 2 is 1 side length and he has 4 sides. It says approximate 4 square root of 2 by first truncating the decimal expansion of square root of 2 to the tenths. So they typed the square root of 2 into their calculator and it gave them all these pretty numbers, and then they said, we don't care about all those numbers. We're just going to go to the tenths place. And for the tenths place, we're going to say, great. Now we're going to say that the square root of 2 is going to be between 1.4 and 1.5. Yeah, okay, yeah, sure, that's good enough. And then from here, what are they going to do? Well, now they have to take and multiply some numbers. They said they multiply the 1.4, and that's going to be 5.6. They multiply the 1.5 times 4, and that gives them 6 meters total. So you could say 4 times the square root of 2 is going to be greater than 5.6, but it's going to be less than 6.0. And they came up with these numbers once again. They truncated to the 1.4, and then it was going to be between 1.4 and 1.5. Now remember, it was pretty close to 1.41, I think was the next number, so it's pretty dang close to 1.4. But it says, therefore, he will need to buy between 5.6 and 6 meters of fence. Therefore, he should buy 5. Nope, 5 isn't going to be enough. I'm going to say 6 meters must be what he needs to buy. 6 meters will be enough to cover his little pen. Now, think about this for just a second. That meant each side of that puppy's pen is 1.4 meters. Less than 1.5 meters. 1 meter's 3 feet. So that poor puppy's pen is only like 5 feet by 5 feet. That's a pretty small pen for a puppy to play in. Now it's going to be your turn. Work this problem where Kelly, hey, that's my wife's name, needs to put a trim around a circular tablecloth with a diameter of 36 inches. The equation, circumference is equal to pi times diameter, can be used to determine how much trim she should buy. So from there, Kelly should buy blank inches of trim. And we even have options here. Wow, look at all those. You work the problem, figure out what your answer is, and then we're going to go from there. Did you get it done? I hope so. Now we're going to go all uppity here and use a fancy calculator on this one so we can have lots of decimal spaces, and that way we can truncate these decimal spaces. From there, we're going to take and bring up my handy dandy calculator, and I'm going to take and say, well, circumference is equal to pi times the diameter. Therefore, it's going to be pi times the diameter was 36 inches. So I'm going to do pi, which is all those many numbers and then some, times the 36, and that means that we're going to be looking at 113.097 yada 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 decimal spaces. So I'm just going to truncate that to be 113.0. Okay, now 113.0 or 113, that's going to be the bottom side of what that should have been, because if you notice our number right here, that number is a number bigger than 113. Therefore, the amount that we're going to need is going to have to be somewhere greater than 113 but less than 114. If you buy 113, you're not going to have enough material. Buy 114, yep, then you're going to have enough material. Jump back over here to our answer, pick 114, hit check, and we win. It really is that simple. Now normally I work the apply problems for you, but this one's not really that hard. All it really wants you to do is estimate the sum of 1 and the square root of 5 all divided by 2. So how about you guys take a minute and do that, and then we will see what kind of answers you come up with. Well, let's see. First thing I need to do is come up with a decent estimate for what the square root of 5 is going to be. And to do that, I'm going to take and start off by taking the square root of 5, and I'm going to look for the perfect squares that are near it. Well, the square root of 4 is really close to it, and that would, and on the other side, you've got the square root of 9. Square root of 4, that's going to be 2. 2 is going to be less than the square root of 5, which is going to in turn be less than 9. I'm sorry, I shouldn't have put a 9 there. I should have put a 3 there, because the square root of 9 is 3. Now, 5 is closer to 4 than it is to 9. So that means I'm going to say that the square root of 5 is going to be about 2. Now, I honestly don't know if they're going to be rounding to the nearest whole numbers for this, or what kind of guidelines they really laid out for us. So I'm going to take the easy route and say 2. From there, that means I can put 1 plus 2 divided by 2. Of course, 1 plus 2 becomes 3 divided by 2, which means our answer would be 1.5 or 1 1/2. I'm going to jump back over here and let's find out whether or not the estimate that I came up with is going to work. So I'm going to just type in 1.5, check. Woohoo! They picked the same number I did. Life is good. Cats and dogs live together with smiles on their faces. Now it's time for you guys to get busy doing your homework assignment. Make sure you give me good quality supporting work, just like I showed you in these examples, so you can get full credit on your assignment. Have a good night.